So hello everyone, welcome to the YouTube channel of DCC NIT-A. So today we are going to discuss the daily question of Leetcode, that is 1020 number of enclaves. So in this question we are given a M cross n binary matrix where 0 represents the C cell and 1 represents the land cell. So in one move we can move from one land cell to another land cell in 4 different directions, that is top, bottom, left and right. So what the question asks is return the number of land cells for which we cannot walk off the boundary of the grid in any number of moves. So the question says that we have given a 2D matrix where it contains zeros as well as ones. So the land cells which are not directly or indirectly connected to the boundary. So let's check out this example here. So in this example, we can see that we have one land cell that is connected to the boundary. So we can see that after this we don't have any land cells. That is, we have 3 land cells left out unvisited. So in this case, answer would be 3 because it is not connected to the boundary in any means. Let's check out another example. In this example, we can see that we have one land cell here which is connected to a boundary. We have another land cell here which is connected to a boundary. We have another land cell here which is connected to this land cell which is ultimately connected to a boundary. Again, we have similarly this land cell which is connected here again, and connected here to the boundary again. So after this traversal, we don't find any land cell left out, and in this case, the answer would be equals to 0. Let's check out one more last example. In this example, we can see that we have one land cell connected to the boundary, another land cell connected to the boundary, another one connected to the boundary. In the second row, we have one land cell connected to the boundary. This land cell is not connected to any other land cell, so we don't need to touch this. This land cell is connected to the boundary. In the third row, we can see that this land is connected to the boundary. And again, this land cell is connected here, which is ultimately connected to the boundary. Similarly goes with this, is connected to this and this and this. Similarly with this and to the boundary. Same goes here. In the fourth row, we can see that this is connected to the boundary directly. This is also connected to the boundary directly. So let's look out the implementation and approach for this question. So basically we need to check for all the adjacent in all the 4 different directions. So in this case, we would be traversing for the boundary elements. So let's check it out. And here we would be using a queue data structure. So for the first row, we don't find any boundary elements. In the second row, we find one. So let's push it. Let's push the coordinates. That is 1, 0. We have pushed in. Let's pop it and check out for all the element land cells in the 4 different directions. In the top, we don't find any. In the right, we don't find any. Same goes with the bottom. And left is restricted. So we have completed for this traversal. Now is there any other boundary elements left? No. So after we have completed our traversal, and we can see that we have 3 land cells that are unvisited. So in this case, answer would be equals to 3. Let's go to the second example. In this example, for the first row, we have found one boundary element, that is 0, 1. Now we need to check for all the different directions. Let's pop it, and in the top it is restricted. Left we don't find any land cell, bottom we don't find any land cell, right we find a land cell. So let's push in, that is 0, 2. So let's check out for this. In this, left is already visited, top is restricted, right there is no land cell. We find one land cell at the bottom. So let's push in, that is 1, 2. Now let's check for this cell. Left there is no land cell, right there is no land cell, top is already visited, bottom we find one land cell. Let's push in 2, 2. Now let's check for this one. Left we don't have any land cell, right we don't have any land cell, bottom we don't have any land cell, top is already visited. So as you can see that all the land cells are visited, but we started from this land cell, so we need to check for all the other different boundaries answers as well. So next boundary cell is this one, that is 0, 2. But as we can see, this is already visited, so we don't need to traverse it again. So we have completed our traversal, and we can find that there is no land cells that are left unvisited. So in this case, answer would be equals to 0. Let's check out for the third example as well. So in this case, for the first row, this is the boundary element. Let's push in, that is 0, 1. There is no land cell at the left, no land cell at the right, no land cell at the bottom. Top is already restricted. So we have completed this traversal. So let's push in the next boundary element, that is 0, 4. Now let's check out for this. Left there is no land cell, top is restricted, bottom there is no land cell, and we find the land cell at the right. So let's push in, that is 0, 5. So for this, we need to check again. So at the left, it is already visited, top is restricted, right is restricted, bottom we don't have any land cell. So the first row is completed and the queue is empty. So for the next, row, we would check it out. So this is 1 comma 0. For 1 comma 0, let's check it out. Top, there is no land cell. Right, there is no land cell. Left, it is restricted. Bottom, we find one land cell. Let's push in. That is 2 comma 0. Now for this 2 comma 0, let's check it out. Top, we have already visited. Right, we don't find any land cell. Bottom, we don't find any land cell. And left, it is restricted. So we have completed our traversal and we find that queue is empty. Now for the third row, let's check it out. For the third row, this is our boundary land cell. So let's push in 3 comma 5. Now let's check it out for this. For 3 comma 5, we don't have any land cell at the top. Right is restricted. We find a land cell at the left as well as at the bottom. So let's push it in the queue. This would be like 3 comma 4 and next would be 4 comma 5. So let's check it out for this element. Pop it. At the left, we find one land element. Top, we don't find. Bottom, we don't find. Right is already visited. So let's push in the left one. That is 3 comma 3. Now let's check it out. This is visited. Yeah. Now let's check it out for this one. 4 comma 5. This 4 comma 5 is here. At the top, it is already visited. Right is restricted. Bottom is restricted. Left, there is no land cell. So we have completed a traversal for 4 comma 5. Now let's check for 3 comma 3. For 3 comma 3, top, there is no land cell. Right, already visited. Bottom, there is no land cell. Left, we find one land cell. That is 3 comma 2. Let's push it here. Now let's check out for 3 comma 2. Top, there is no land cell. Left, we find one land cell. Bottom, there is no land cell. Right is already visited. So for the left one, let's push it. That is 3 comma 1. Now let's check out for 3 comma 1. For 3 comma 1, left, there is no land cell. Top, there is no land cell. Right is already visited. Bottom, we find one land cell. That is 4 comma 1. Now let's check out for 4 comma 1. For 4 comma 1, left, there is no land cell. Right, there is no land cell. Bottom, restricted. Top, already visited. So as we can see, we started from this land cell. Now for the fourth row, we have this boundary cell which is already visited, so we don't need to traverse here. Again, this one, it is already visited, so we don't need to traverse here. So we have completed our complete traversal and we can see that one land cell is left out unvisited. So answer would be equals to 1. So now let's move on to the coding part. So let's start with the coding part. So in this case, we would be using a breadth first search traversal where we would be creating a visited array that would determine whether the land cell is visited or not. So first we would be taking the row size, then the column size, and next we would be traversing through the rows. Like for the first column, grid I comma 0, and for the last column, that is grid I comma n minus 1, and we would check whether it is visited or not. And for every visiting, we would be doing a BFS traversal. Same goes with the row part. We would be traversing through the columns, and for the first row and as well as for the last row, that is m minus 1th index, we would be doing BFS traversal for both the things. So let's move on to the BFS. So we have created a breadth first search function where we are taking the row and column as input and the size of the matrix, and we are also taking in the grid that was given to us. So we have initially created a queue data structure which has a vector in it. So basically we would be inserting the coordinates in the queue. So for the queue, we have inserted the rows and columns which was given for us. We have posted here, and we have make it non-visited. So we have created two vectors here, that is index of x and index of y, which would be used for traversing through all the four directions. That is -1, 0, 0, 1, 0, -1, and 1, 0. So basically these are the four different coordinates that would be added to the original index for traversing to the left, right, top, and bottom. So let's move ahead. So while the queue is not empty, we would check for the front row of the front element of the queue. The first index would be the row and the second index would be the column. So we would be popping it out, and now we would check out for all the four directions. So we would be adding that index which we created here. These two vectors are the indexes that we have subtracted or added to the original element for the left, right, top, and bottom. So we have first created the base case, that is if the row we get left of 0, that is less than 0, so that it is not out of range, -1. So we will ignore that. Or if the column is less than 0, or if the row is greater than m, or the column is greater than n. So in that case we would ignore that. Else, if the grid that we are using it now, if that is equals to 1, that is means if the grid the element is a land cell and it is not visited, that is equal to 0. So we would push the index of coordinates of that element, that is row plus idxi and column plus idxy, and we will make that visited. So again, we would be checking for that element similarly, which goes. So at last, we would be counting the number of elements land cells that are unvisited. So we would be traversing through the 2D matrix, and if that is a land cell and it is unvisited, so we would be increasing the count and we would be returning the final answer. So let's run it. Successful. Let's submit it. So as you can see, this breadth first search is completed.